Hello, good morning, and welcome sa ating lesson about integration by trigonometric substitution. Under this topic, the main objective is learn and use correctly the trigonometric substitution. Under this topic class, we have three formulas. Okay, so first is when the integrand involves a squared minus x squared, so the solution is to try x equals a sine theta. So second is when the integrand involves a squared plus x squared, so try x equals a tangent theta. And number 3, when the integrand involves x squared minus a squared, try x equals a secant theta. So ito lang po class yung tatandaan nyo kapag trigonometric substitution. So tingnan nyo lang po yung integrand kapag may nakikita po kayo na ganitong format. Yung a po is a constant. So pwede po siyang mga perfect square, yung ilagay, like 9. So, pwede siyang gawing 3 squared, let's say 16, pwede siyang gawing 4 squared, and itong a squared, pwedeng let's say 25, pwedeng gawing 5 squared. So, kapag ganun po, depende kung ano lang yung nauna. Kung constant, nauna siya, squared minus x squared, ito po yung solution. So, dito tayo mag-start. So, yung initial solution is to let x equals a sine theta. So, once na nauna yung a squared followed by x squared, so ito na po yung magiging start ng solution. So, you're going to let x equals a tangent theta. At kapag nauna yung x naka-squared minus the constant squared, so the solution is to let x equals a secant theta. So, madali siyang maintindihan by means of example. So, kaya proceed tayo sa example number 1. This is question number 1, page 261 in your textbook. We have evaluate the integral of dx over a squared plus x squared raised to 300. So, again, at tinitingnan lang class dito ay yung integrand. So, kung meron po nung tatlo. So, dito nakita natin, we have a squared plus x squared. So, but you need to analyze carefully the problem. Kasi baka naman yung problem na binigay, although nandito siya sa format ng a squared plus x squared, baka naman may ibang formula. So, pero ito kasi class, if we observe, yung a squared plus x squared, wala tayong nakikitang derivative sa numerator. So, hindi naman siya pwedeng gawing power formula. So, it means, pag ganito po, we can now apply the trigonometric substitution. So, dito, since a squared plus x squared, ignore nyo lang yung raised to 3/2. Ito kasi yung focus natin. So, the solution is to let x equals a tangent theta. So, automatic na po yan kasi yung format, exact na siya dun sa list ng formulas na binigay, no? And then after this, let x equals tangent theta. Again, this is a trigonometric substitution. So the next thing that you need to do is to solve for tangent theta. Pwede natin kunin yung tangent theta. So tangent theta is x over a. Itong purpose class ng x over a, since we introduce a new variable which is tangent theta, so kailangan makuha natin yung value niya in terms of the original given, no, which is we have x and a, yung variable natin dito. Variable x, and we have a constant a. So the tangent theta is just the ratio of x over a, and pwede kayong gumawa ng triangle, simple right triangle. Yung tangent theta is opposite over adjacent. So depende sa angle kung saan nyo ilalagay. Let's say nandito yung reference angle natin. So therefore, yung opposite is dito, yung adjacent dito. Ito naman is Pythagorean theorem. So we simply square itong a saka yung x, then take the square root so that we have the hypotenuse. So, ang sunod po is, i-differentiate na natin yung let x equals a tangent theta. By the way, yung triangle pwedeng sa last part ng solution gawin. So, depende naman yan kasi sa last part pa siya gagawin itong triangle natin kasi magkakaroon ulit tayo ng substitution. Okay, i-differentiate lang natin yung x, and that is dx. A tangent theta, the derivative is just a secant squared theta d theta. So by the way, in this topic pala class, most of the formulas po na ginagamit dito is under integration by trigonometric functions, and meron din po siyang transformation by trigonometric formulas, and commonly gumagamit dito ng mga identities. So yung identities po natin, yung common identities, yung mga Pythagorean identities, yung 1 plus tangent squared theta is equal to secant squared theta. So, dapat alam niyo po yan, no? So, yung 1 plus cotangent squared theta equals to cosecant squared theta. At yung sine squared theta plus cosine squared theta equals 1, no? So, ginagamit din niya na identities. And sometimes yung uh, sine and cosine na even number yung exponent. Let's say sine squared theta. That is 1 minus cosine 2 theta over 2 minus yung sine, no? Yung cosine squared theta is plus naman yun. 1 plus cosine 2 theta over 2. So, and power formula, kung makita nyo po na power formula, so kasama rin yan. And then, minsan naglulugarithms. And marami po dito identities. Okay, so yun na po yun na. So at least aware po kayo na kapag trigonometric substitution, so kailangan po na i-review po yun. Okay, so after po ng differentiation, ang next step is change variable po tayo. Okay, substitution. Yung dx, meron ng new value, a second squared theta, d theta. Yan, ipa-plug in na natin dito. Ito na siya. Then, yung a squared copy, yung x naka-squared, since ang x ay a tangent theta, squared mo siya, that is a squared tangent squared theta raised to 3 halves. So, pagkatapos po nun, okay, nag-change variable na tayo from x, naging trigonometric function na siya kasi theta na yan, no? Second squared theta and tangent squared theta. So, ang sunod po, isi-simplify natin. So, unahin natin yung denominator kasi may a squared dito na common factor and naka-raise sa 3 halves. Pwedeng i-factor out yung a squared pero naka-raise sa 3 halves. So, basically, law of exponent, makakancel po yung 2 kasi a squared raised to 3 halves, just multiply 2 by 3 halves and that is a cube. Okay na po yan. Then, pag pinactor out mo, syempre, you need to divide yung a squared dito. So, matitira 1 plus tangent squared theta raised to 3 halves. And ito na yung na-mention ko before, na yung 1 plus tangent squared theta is may identities po siya na second squared theta. Diba? And then, raised to 3 halves. No. Ngayon, yung pwedeng i-cancel, ika-cancel natin. Let's say a cube, cancel ka na. Di meron ka na lang 1 over a squared. Ngayon, every constant na hindi naman derivative, much better ilabas sa integral sign. So, since this is a denominator, so ilabas natin 1 over a squared. Then we have now the integral of second squared theta d theta over second cube theta. So, ang sunod pong gagawin, simplify ulit. O, pag sinimplify, syempre, cancel na yung second squared theta. So, may matitira tayo na second theta sa denominator. So, ngayon, pagdating po dyan, this is a new problem. So, it means after trigonometric substitution, yung problem natin na integral of dx over a squared plus x squared raised to 3 halves is naging integral na lang ng 1 over a squared times the integral of d theta over second theta. So, our goal now is to integrate d theta over second theta. So, hahanapan natin siya ng formula. So, paano? Since this is a trigonometric function, so pwede tayo bumalik doon sa trigonometric function. So, pero wala naman siyang direct integral, di ba? Wala naman direct integral tayo na ganito kasi yung 6 trigonometric functions, na-discuss na natin yan. So, depende na lang po doon sa list ng mga formula natin kung pasok si 1 over second theta. Wala naman, pero kapag tinaas natin, we know na ang second theta, pag nireciprocal natin, is nagiging cosine theta. Ngayon, yung cosine theta, ayun, may integral. And that is positive sine theta. Ayun, no? Ganun na yun, no? So, pagkatapos, since yung variable natin dito is theta, but the original variable is x, so we need to substitute again the actual value, no, of sine theta. So, yung sine theta, yun, doon na po natin gagamitin yung triangle. Kasi yung sine theta is just opposite over hypotenuse. So, ito yung theta natin. So, yung opposite side is x. Ipa-plug in natin yan dito, x. Then, yung hypotenuse is square root of a squared plus x squared. Ayun. Yun ang purpose bakit may triangle dito. Then, after this, ayun, saka na natin isi-simplify. So, the integral now of dx over a squared plus x squared raised to 3 halves is equals to x over a squared times the square root of a squared plus x squared plus c. Ayan. So, ganyan po yan sa trigonometric substitution. So, by the way, itong problem na to is pwede rin i-solve using algebraic substitution. So, depende na yan sa inyo, pero ang trigonometric substitution, madali naman siyang sundan, provided na alam niyo po yung mga formulas na ginagamit dito. So, hindi naman siya napaka-complex. Kayang-kaya siyang matutunan. Okay? And this is the solution. So, for first example, number 1, page 261 in your textbook. So now, we will now proceed to the second example, and This is number 5 in your textbook, page 261. So we have evaluate the integral of the square root of a squared minus x squared dx over x squared. Again, ang tinitingnan lang po yung integrand kung anong meron. So a squared minus x squared is ito po yun, let x equals a sine theta. 'Di ba? Yun yung formula na gagamitin. So it means let us use this. So and then you can solve for sine theta. So sine theta is just divide both sides by a, so x over a. Yung triangle, pwede naman last part na natin gawin. So, and then differentiate x equals a sine theta, and that is dx equals a cosine theta d theta. Then, substitution. So, mag-change variable po tayo. So, from the integral of the square root of a squared minus x squared dx over x squared, yung x, ipapalit natin yung a sine theta, but we need to squared. So, that's why we have a squared minus a squared sine squared theta over yung x is naka-squared sa denominator, means we need to square this. So, we have a squared sine squared theta. And don't forget, yung dx is may new value na a cosine theta, d theta. So, yan. Lahat po, papalitan yan. So, and then after this is simplify na lang natin. Okay? Pag simplify po, first of all, yung a saka a squared dito, we can now cancel out yung isang a. So, may matitira pang isang a sa denominator, no? Cosine theta and sine squared theta, so i-retain muna natin. But here, yung a squared minus a squared sine squared theta is we can factor out a squared, and we can factor out, at yung 1 minus sine squared theta is cosine squared theta, right? And we can take the square root of a squared cosine squared theta kasi perfect square. So, ang magiging square root niyan is just a, since ang square root ng cosine squared theta is cosine theta at meron kang naka-times na cosine theta, so magiging cosine squared theta d theta over a sine squared theta. So, yung a is makakancel, so magkakaroon na lang tayo ng cosine squared theta over sine squared theta. Again, ang goal is ma-integrate, kaya hahanapan nyo po yan ng formula kung nai-integrate ba ang cosine squared theta d theta over sine squared theta. So, ang sagot hindi, no? Hindi mo naman siya ma-integrate kasi wala tayong formula. So, ang gagawin ulit, pag ganun po, every time na hindi mo siya ma-integrate, trigonometric identities lang class ang solution. So, it means yung cosine squared theta over sine squared theta ay may identities na cotangent squared theta. Okay, di ba yung cotangent theta is just the ratio of cosine theta over sine. So kung naka-squared, pwede naman i-squared yung cosine squared theta over sine squared theta. That's why yung identities is naging cotangent squared theta. So, again, this is a trigonometric function, kaya ang laging i-recall yung formula sa integration of trigonometric function. So, ang tanong, meron bang integral ang cotangent squared theta, d theta? Nandun ba siya sa list ng formula? Ang sagot, wala. So, pag wala po, ibig sabihin, another trigonometric identities. Ganun po, trigonometric identities lagi. Hanggat wala kang nakikitang integral. So, cotangent squared theta, d theta, anong identities? Okay. And that is cosecant squared theta minus 1. Ayan. So, di ko na masyadong explain yung identities kasi ang tagal na natin pinag-uusapan yan. No? So, by the way, Pythagorean identities lang naman yung ginagamit natin dito at madalas, yan po yung ginagamit, no? So, 1 plus cotangent squared theta is just cosecant squared theta. So, kaya yung cotangent squared theta is just cosecant squared theta minus 1. Okay. So, pagdating dito, we can now separate this, no? Paghihiwalay natin, we have the integral of cosecant squared theta minus the integral of d theta. Okay. Yung bang integral ng cosecant squared theta d theta is may integral? Yes, no? Kasi nandun yan sa formula. Exact na yan. Ang integral niyan is negative cotangent theta. At integral ng d theta is just theta. So, ngayon, na-integrate na natin. Pero, ang mapapansin nyo, naging trigonometric function. But the original variable is x. So, that's why ibabalik po natin. So, in this case, gagamitin natin yung triangle. So, paano gamitin yung triangle? So, we have sine theta equals x over a. It means, lagay nyo muna yung reference angle theta. So, ang sine theta is opposite over hypotenuse. Kaya dito nyo ilalagay yung x. Dito yung a, no? Kasi opposite over hypotenuse. So, ito naman is nakukompute lang to using Pythagorean theorem. So, a squared minus x squared. Square root nun is yung adjacent side. Okay. Since theta, yung nakalagay dito, tatlo po yung possible na sagot dyan, no? Unahin natin yung cotangent theta. So, cotangent theta is just reciprocal of tangent theta. So, mas madali kasi yan. ang tangent theta is opposite over adjacent. Di ba? Opposite over adjacent is tangent theta. So kung cotangent, babalik na rin mo lang yan. Reciprocal mo lang. Adjacent over opposite. Kaya yung adjacent side is square root of a squared minus x squared and the opposite side is x. And that is for cotangent theta. So negative. So andito naman po yung negative. Nakalagay naman po siya dito. No? Okay. Sa angle po, may tatlo. Pwedeng arc sine x over a. Ibig sabihin, kung arc sine ang gagamitin mo, that is opposite over hypotenuse. That's why opposite side is x, hypotenuse is a. That's why we have arc sine. No, kumbaga sa calculator, if this is a triangle and this is 1 and this is 2 and you need to compute the angle kung ilang degrees, ang ginagawa lang po doon, opposite over hypotenuse is a function of sine, you need to divide. 1 over 2, shift sine sa calculator, lalabas yung sagot na 30 degrees. No? So, pero kung ganitong variable, ang pagsulat po nun is simply arc sine. No? Yung shift sine, papalitan nyo ng arc sine, opposite over hypotenuse. And that's it. We have now the answer. And pwede rin po, class, na gamitin yung arc tangent. So, arc tangent is just opposite over adjacent. That's why we have the opposite side of x and adjacent side of square root of a squared minus x squared. This is arc tangent. Kung arc cosine naman, arc cosine is simply cosine, di ba? Ang cosine is adjacent over hypotenuse. So we have adjacent side is square root of a squared minus x squared over hypotenuse a plus c. So pwede rin yun sa arc cosine. And that's it. Yun na po yung magiging answer natin for this example. Okay. So ang sunod po dito is simply yung example number 3. So dagdagan natin. This is number 6, page 261. So the given here is we have the integral of dx over x squared minus a squared raised to 3m. So dito sa example, didiscuss ko lang po yung tatlong formula, paano gamitin yung let x equals a tangent theta, let x equals a sin theta, at yung let x equals a secant theta. Yung let x equals secant theta is ginagamit po siya kapag ka nauna yung x squared minus x a squared. So dito po, let x equals a secant theta. You can solve for secant theta, and that is the ratio of x over a. Pwede rin na cosine theta, reciprocal, that is a over x. So, i-differentiate lang natin ang x equals a secant theta, and that is a secant theta tangent theta d theta. Ang sunod is substitution. Change variable. So, yung dx is now a secant theta d theta over yung x squared is now x is a secant theta just squared. So, we have a squared secant squared theta minus a squared raised to 3 halves. Simplify. So, a secant theta tangent theta d theta, just copy. Yung a squared secant squared theta minus a squared raised to 3 halves is we can factor out first yung a squared so that we have a squared times secant squared theta minus 1 raised to 3 halves. Then, don't forget na yung secant squared theta minus 1 ay may identities na tangent squared theta. No? By the way, yung pong a squared raised to 3 halves is pwede na natin gawin na a cubed. No? Tapos yung secant squared theta minus 1, that is tangent squared theta raised to 3 halves. Again, makakancel yung exponent na 2. So, magiging tangent cube theta. And then, after this cancellation, ano yung mga pwedeng i-cancel? So, dito yung a, saka a cube, tanggal na yung isa. So, a squared na lang. Tangent theta and tangent cube, tanggal ulit yung isa. And that is, we have yung a squared, pwedeng ilabas yan. That is 1 over a squared. Meron pa tayo matitirang secant theta sa numerator. Pero sa denominator is meron matitira na tangent squared theta. So, pagdating po dito, this is a trigonometric function. Again, balik tayo din sa previous lessons. Hanapan niyo po siya ng integral. So basically, pag wala kayong makitang integral, let's say, hindi naman siya power formula. No? Kasi pag tinaas mo yung tangent squared theta, ang derivative ng tangent is secant squared. Kaso secant theta. Bitid, no? O pag ganun, identities, no? Yung identities, ang secant theta is 1 over cosine theta. At yung tangent squared theta is sine squared theta over cosine squared theta. So, using complex fractions, arrow techniques, so we have, dito yung cosine theta, makakancel yung isa, meron ka pang isang cosine theta sa numerator, at yung sine squared theta, so times 1, and that is sine squared theta. So, pagdating dito, another identities, hanapan nyo na naman, may integral ba? Well, may exponent na to, pwedeng itaas, magiging sine, no? Sin theta raised to negative 2 cosine theta d theta. So, ibig sabihin, ang derivative ng sine is cosine theta. Ayun, pwedeng ma-integrate. Power formula, no? So, ibig sabihin, power of formula, just add 1 to the exponent. So, it means magiging negative sign kasi sine raised to negative 2 plus 1 is sine raised to negative 1 over negative 1. So, positive yung given, so magne-negative tayo. Pero basically, ang sine raised to negative 1 po is, ang ginagawa po dyan is ginagawang positive yan. Kasi dapat magamit natin yung triangle, no? So, kaya pag ganito class, ibaba nyo lang sa denominator, so magiging positive sine theta. Tapos pag tinaas nyo, so magiging cosecant theta. So, it means kapag ka sine raised to negative 1 po, that is just equals to cosecant theta. Yun lang po ang equivalent niya, no? And then, pwede na natin gamitin yung triangle natin kasi yung cosecant theta, so makukuha natin yung value dun sa triangle. Okay, well, yung secant theta is x over a. Again, yung secant theta is reciprocal ng cosine. Yung cosine kasi is adjacent over hypotenuse. Yun yung adjacent. Yun yung adjacent over hypotenuse. That is cosine, no? Adjacent over hypotenuse is a function of cosine. So, pag sinabing secant, balik na rin nyo. That is hypotenuse over adjacent. So, it means yung x ilalagay nyo sa hypotenuse, yung a ilalagay nyo po sa adjacent. So, syempre ito, Pythagorean theorem, laging hypotenuse squared minus yung adjacent side a squared. So, therefore, from here, pwede natin hanapin yung value ng cosecant theta. Again, cosecant is reciprocal ng sine. Ang sine is opposite over hypotenuse. O, di balik ta rin yun naman. Hypotenuse over opposites. Kaya dito, ang mangyayari, hypotenuse is x, and opposite is square root of x squared minus a squared. Then, multiply natin, and that is negative x over a squared times, we have x squared minus a squared plus c. So, yun na yung tatlong types class ng trigonometric substitution. So, again, much better kung ulitin nyo na lang po yung example, pag-aralang mabuti kung paano ginagawa. So, may mga identities na involved. So, yun po yung paghahandaan nyo rito, no? And for your task, meron akong 3 items na binigay dito. Let's say 2 points each, o pwede ko pang dagdagan to 3 points. Okay, ang gagawin po, kindly submit your solution. So, may answer key na ako dito. So, kung wala pong, kung mali yung answer nyo, so pakiulit po yung solution kasi maybe may problema sa process na ginamit po ninyo kasi yan na po yung answer key. Okay, so we will continue this topic. So yung second part ng video, yung additional examples, no? So kasi kulang na yung oras ko, no? Okay, sana may natutunan po kayo dito sa lesson na integration by trigonometric substitution. So, by the way, yung mga formula po na kailangan na nakita nyo po, especially trigonometric identities, so integration of trigonometric functions, so kailangan pong i-review yun kasi yun po talaga yung ginagamit dito sa topic na to. Okay, so hanggang dito lang muna tayo class and thank you very much. So abangan nyo na lang po yung next video para sa additional examples. Bye-bye!